Solving logarithmic equations. All right, so let's get started with these. First example, solve the logarithmic equation using the definition of logarithms. So again, before we get too far into what we're doing, let's write down how to change something from an exponential into a log. So based on the definition, then this means I take log base b of the value, which is y, is equal to the exponent. Again, the job of the exponent is to find, try that again. The job of the log is to find the exponent. So looking here, now I have to go back to some of the rules that we know with just solving equations. I need to get this log by itself. So in order for me to get this log part by itself, I'm going to divide both sides by 5 because I have 5 times the log. So now I get log base 7 of n is equal to 2. So one thing that I've seen in the process of doing logs all these years is you take and you do kind of like an arrow around to bring you back to what you need. So it's going to be 7 squared equals whatever's here. So 7 squared is equal to n, so therefore n equals 49. Okay, so an easy way to go from log to exponent is just to do this little cycle around and back through. All right, next question. In this case, we've got logarithms on both sides, in this case the natural log. So just like the work we've done with exponentials, if the bases are the same in an exponential, then just the exponents equal each other. Well, here, if I have the same logarithm on both sides, and I've got it simplified down to a single log on one side and a single log on the other side, then I can let those logs disappear, because the only way that this works is if this is equal to this. So let's go ahead and do that. So now that means I have x squared is equal to 2x plus 3. I've got a quadratic, so I'm going to have to go back to the stuff we knew about quadratics, solve a quadratic. So to solve a quadratic, I move everybody to one side, which then makes it equal 0. Now I'm going to factor. So I've got an x in each term in the beginning. This tells me the signs are different, so I always, for some reason, put a plus sign first. And then I need factors of 3 that differ by 2, with the larger number being the negative. So 3 goes here, and then my 1 goes here. So that means now x is equal to -1, 3. Now, remember, I cannot take the log of a negative number, so that means I've got to go through, take this value, substitute into here, and see what happens. So if I let x equal -1, then I get ln, well, let's see, -1 squared is going to be 1, is equal to ln of 1 times -2, so that's going to be -2 plus 3. So I actually get ln of 1 is equal to ln of 1. So even though this is negative, it doesn't mean that that doesn't work. So now I got to take 3 and substitute 3 in. So if x is equal to a 3, then I get ln of 9 is equal to ln of 2 times 3 plus 3 more. So that's going to be 6 plus 3, that's 9. So this one works as well. So actually, it's both of these values work. There's no extraneous roots in this case. All right, now before we move on to the final one that I want to do with you, I need to remind you of some of the log properties. These are things that you've done in Algebra 2, but they we may not have gone through and talked too much about them in this year's course. However, these are things that you need to know. So if I have a product, then that turns into the addition of the logs. And the same thing goes in reverse. If I have 2 logarithms of the same base being added together, then it's the product. Here, if I have subtraction, it's going to be division. And then here, if I have the log base b of something raised to a power, then remember that power comes out. And then the change of base formula. So in case I need to switch something from base 5 to base 10, this is the way at which we can do that. So the reason for rehashing all of that stuff from the last slide is to help us solve this equation here. So if I look at this particular equation, this leads us to knowing I have to use the property for subtraction here. What do I do when I have subtraction? It's not actually the property of subtraction, sorry, it's the division property for logarithms. But I'm going to go through and now change this into a singular log. So in order to do that, remember the way the properties were written is if the two logs with the same base, notice all of them have the same base, but if these two have the same base and I subtract, then it gets rewritten, try that again, as x plus 6 divided by x. And then this side doesn't have to be rewritten, it just has to be rewritten as log, there we go, base 8 of 58. Now, just like the work that we did with the exponentials and in the last problem when we had logs that were the same on both sides, since the logs are the same, the only way that these two things will equal each other is if the stuff following the log is the same. So I have now x plus 6 divided by x is equal to 58. Solve, so I need to move this x to this side, so I get x plus 6 is equal to 58 times x. Subtract x from both sides, so now I'm going to have 6 is equal to 57x, which then means x is equal to 6/57ths. And you can leave it as 6/57ths, okay? And then I'm going to substitute this back in just to see if it gives me anything that is not allowed. Remember, I'm not allowed to take the log of a negative number because it's not defined. It doesn't work that way. So if I take 6/57ths and put it in there, then it's fine because it's a positive number. If I put 6/57ths in here, it's also fine. No issues. All right, so then this one, even though here I was told that it can't be 0, which we know it can't be 0 anyway, so therefore this is my only solution. Okay. All right, so hopefully this was helpful. It goes through and it went with the different types of log equations that you can solve, and it's just a couple of them. Of course, we can't possibly cover every single type of equation that you would have to solve, but this, based on the other information that you know about logarithms, will help you to solve log equations. Thank you, and have a great rest of your day.